Hi everybody! Hopefully we are finally live. So, first of all, I have to excuse because of downsample the resolution to HD, not full HD, and also today we experience like a huge latency. I'm like 2 minutes before you, so let's try. So, and in anyway, if something goes wrong, please excuse me again because today is today's connection is just crazy. So before we start, let's discuss questions. How we can chat with each other. First of all, we have YouTube chat here, and the second option, which is also available between the streams, is our Discord channel. And please, if you are not in our Discord, just you can ask us any questions at any time in Discord and chat about anything. So today's stream. Today's stream it's actually a very important now, and many things which relates to GeoTracker we discussed last time. So if you missed the stream, please find time to take a look at it as well. Today we are going to speak about some basics stuff in GeoTracker, and the next time we'll discuss some tips, tricks, some complex cases, some best practices, and so on. So actually it's just the long stream. It would be a very long stream if I put everything put everything inside. So I decided to split it in two parts. And the last stream about GeoTracker, the third one, will be about deformable tracking. Okay, but today, just basics. It will be just general overview, but pretty with lots of deep dives. Okay, so, but I'm gonna make it a bit half theoretical, because first of all, I want to discuss what actually geometry tracking is and why people use it. So probably the main reason to use geometry tracking, so geometry tracking in general is just when you want to track an object or some basically object with some knowledge of its geometry. So you try to reconstruct 3D movement of the object based on 2D information from the camera, and you know the geometry. Why it's a bit different from the traditional tracking when you have no knowledge about geometry and you track features independently, and then you can reconstruct geometry and camera movement together, and it's called, in mathematics it's called bundle adjustment. But geometry tracking is a bit simpler task, and it's widely popular mostly because it can significantly speed up all your process. So it seems that it's a bit harder to get the model of the object or the model of the scene, and it needs more attention and more work during the production stage. And for you, for example, as a VFX supervisor, it definitely gives you much more work on stage, and you have to somehow make, we'll discuss it a bit later, get the information about 3D structure of the object or scene. But then later during the tracking you get significantly faster pipeline, and today we are going to discuss what's actually the difference between traditional pipeline without reference geometries and 3D tracking with like geometry tracking with the help of geometry. Okay, oh, I have Nuke here. And the difference basically is that money matters. Okay, what's going on here? Oh, please cancel. Okay, the money matters, and because sometimes it's cheaper to invest your time. Reconnection successful. Okay, hello again. It seems there was kind of a lag in translation. So, returning to the footage, it looks like this. So here we have this creature. Everything is a bit slow again today. I have no idea why. Oop. Sorry for this. Okay. Yeah, everything is terribly slow. And yeah, let's wait while it pre-caches the footage. My laptop is not that fast, especially with OBS Studio. Okay. It's really a small part of this footage. Yeah, so there are two actors. They are in this mask, and here in GeoTracker, and yeah, and I have geometry of this mask. Here it is. It was scanned using structure light, and now let's switch to GeoTracker. Delete any prior tracking, and now I can attach my I can attach this object to the projection. Oop. Yeah, we definitely experienced some problems with my laptop today. So, and actually when I drag these points, if I add one more viewer here, and here it is, and switch to 3D, yeah. So when I drag these points here, oh, slowly, you see it changed its position in 3D. So basically I set up keyframe. Let's do it precisely. Please fix it. And now I can just click track button, and it will track the object. Oh, it seems we have one more. Sorry, there was some strange keyframe over there. Let's delete it. And yeah, click track button again. And it tracks tracks the object using the footage. And if I switch to, let's stop it, everything is really slow. Sorry guys. Probably it's not a connection trouble, probably it's a trouble with my laptop. But anyway, we are in trouble. Can you hear me, guys? Is everything is okay? Yeah, so let's look at the result. So you see the object is moving in 3D, and it's moving in 2D as well. So I will definitely find some interesting examples a bit later. So let's return to the presentation, and I'm gonna show you several more examples, and most of them are from our lovely clients who shared these beautiful breakdowns with us. So people track some simple objects like this, or had to attach some additional objects to them, or cars, vehicles, and automotives, lots of them, to change the models, change cars, reflections, and so on. And also lots of shots with weapons and some bombs and so on. And of course, facial tracking. People tend to track faces a lot, like these shots from Gotham series, and they added this virus effect. Also, GeoTracker supports objects with skeletons, and we'll discuss it in one stream. Not the next one, but the next after the next one. Some manipulation and adding some objects and changing textures, it's just a common scenario for GeoTracker. And yeah, like these shots from Goodbye Kansas and from Walking Dead series. It's a student walk. Yeah, you can even delete some parts. This one is beautiful. Also student walk. They added the face of Albert Einstein. Okay, so who uses now GeoTracker? Many studios all over the world. Quite a lot of them. I even probably don't know big studio that doesn't use GeoTracker now. And let's discuss one more question: why we created this geometry tracker not as standalone but inside the Nuke. And there are several reasons for this. So first of all, it's all about time, because we can, as compositors, we know what to track inside the shot. So we know where this track should be precise, where it could be not that precise. We know, for example, you track the face and you have to add some. If you ask guys from 3D tracking department, they do their best to track the face and get the best tracking they can, but unfortunately some of this it's kind of redundant work, and sometimes you actually can simply track just half of the shot, and the other half you don't need it. So it can simplify the process, and we actually took this "what you see is what you get" approach for whole GeoTracker interface and so on, because in cinema, basically the only thing which is matters what people see at the end. Also, you don't need to re-import, re-export your shot on every change in tracking. If you have some, or which is worse, you have to ask somebody from other department, and it will actually take a lot of time. And time is money. And the cool thing also that in many cases you don't need to ask some people from other departments, and that's great. And the real reason for this was that we love Nuke. We love Nuke, we knew Nuke, and we decided to make it all, everything inside Nuke, because lots of different stuff could be done right inside Nuke without going to some other software, and that's great. Anyway, you have to go to be in Nuke at the end of the process. So the more things you can do inside Nuke, the faster you can walk. Okay, how geometry tracking works. And it's pretty important question, because it's a bit different from the traditional pipeline. So first of all, everything is like from 2D to 3D, and it's basically like any tracking works, but with some small changes when we talk about geometry, because, well, feature is some notable part on a footage. It could be some corner or some blob or something like this, and then with the help of optical flow engine or something like this, we can track the movement of this feature in space of the image, in image space, and we get some trajectory, but this trajectory of the feature will have two coordinates, like x and y, and then we have a 3D engine, and actually, and now we have a bit some difference between 2D with tracking with geometry or without it, because when you have a geometry, you can identify every 2D feature with some point on a surface of the model, and like for example here, let's switch to our tracking. For example, I'm gonna put a pin here on this car, and now when I let's play it. So I put 2D feature, then I can track this 2D feature, but the thing is, this feature has unique position on a surface of the object, and you can always verify and check it, and this knowledge helps us a lot in tracking of this object. When you track the object without the geometry, you have to also find what's actually the 3D coordinates of this 2D feature, and this task is a bit more complex, and it gives a lower quality of the results. Okay, so basically the idea is pretty simple. We track these 2D features, and then we try to find such position of this 3D object that match these 2D features. Obviously, not all trajectories of 2D features are good. Many of them are affected, for example, by some noise or motion blur and so on. They are basically wrong. That's why we need to filter out all wrong features. Then there is one additional step called transact to find the best subset of all features that are moving together to actually find such features that actually relates to the object. And then we can find the 3D position of the object, and it's called perspective and points task. And it's basically what pin tool does. So when you drag features in pin tool, like these pins in pin tool, it actually solves this reconstruction task, which called P&P problem. So it was a small part of theory, and let's now go more to the practice. But before, we're gonna to compare the different approaches. So if you have a geometry tracking, one of the very important thing is that solver is local, because when you don't know 3D positions of the features, the only thing which you know is that this position is the same on all shots. And that's why you have to solve all shots together, like in camera tracker. When you hit solve button, it solves the movement of the object in the whole shot, in all frames. But in GeoTracking, you can track different parts of the shot locally and isolate them using keyframes. And it gives you really better control on your tracking, and you can get the results faster. Also, you can track smaller objects using GeoTracker because you don't need so many features. And the last but very important thing, it's less sensitive to noise. And basically it means that the tracking is more robust. Okay, so let's discuss now everything in details. So what is GeoTracker? It has 4 inputs. GeoTracker. Like pin tool, it has inputs like camera, geometry, background, and one additional input here is mask. So first of all, let's discuss model. First background. Okay, background, and the most important thing you have to know about it, it should be undistorted. So GeoTracker expects undistorted background. So how to undistort it, and what's actually this distortion and where it comes from? It comes from lens, because lenses are not ideal. And to undistort it, you actually can shot a checkerboard and then analyze it in Nuke, and then you can unwrap this distortion and make the straight lines straight again. But please always do not take photos of distortion maps. Take video of them, because sometimes there are some small crops in the matrix, even in professional cameras, and you get the wrong distortion because of it. So please just shoot video with same settings which you use for the shot. And after you undistort the footage, you always need to cache it somehow on the disk, because otherwise, because undistortion process, it's not that fast. It's ST modification of the image, and because we do it quite a lot of times, and cache in Nuke is not that reliable, you'd better always write undistorted footage to the disk. With the help of write node, it's better, because I usually fail to use disk cache node for this. Let's better use just write node. and then read it. Just you have an option in write note for this, like this. Right, and here you choose. You can read the file and use the output of this node, and it's always better than disk cache. All footages which we have here, they are already undistorted, but the thing is that sometimes you can just simply use the original footage, because if the object locates in the center, like here, even if the distortion is relatively big, it's bigger to the borders of the image, and in the center there's usually almost no distortion for most of the lenses. And let's also discuss resolution of the background and how it affects the tracking. So generally, the better resolution, the better tracking you can get. But sometimes you have just excessive number of pixels, and everything is becomes really slow. And sometimes you can down sample, for example, 4K to HD, and everything will work pretty good. And I know quite a lot of studios that use HD pipelines for tracking because of the speed of the everything, and they are happy with the results. And if you are happy with the result, just use a smaller version. Okay, now let's discuss model. We have one question, but you can do it in camera tracking with mask, I think. Because of the latency, probably I can't understand what you are talking about, because you wrote this a bit. Please write without it or something, because I can't understand what we are talking about in this question. Okay, Jordi, just ask it again. How model? Okay, how to get the model? It's just the most common question. And first of all, you can use 3D scanner or LiDAR or something like this, and they give you fast and reliable 3D models, all messy with lots of points, and but you can then retopologize them, make them clean, and use for tracking. Also, the same pipeline with photogrammetry, but photogrammetry works for static objects. The same as structural light scanner. It also usually better works for static objects, but I really like structural light approach because it's really cheap, and you can use just ordinary projector, like LCD projector or DLP projector, and just web camera and some piece of software, for example, like David Laser Scan, and it gives just amazing results. Or you can build the model manually. You can just take several photos from different angles and try to reconstruct it just in 3D package. If you track faces, you can use Face Builder, and it's much faster than any of the methods above. Okay. Also, one more question about the model is how precise the model should be. And well, first of all, I'd say that it should be so it should describe the geometry. So there should be the smallest number of polygons which describes the geometry. What I mean by describing geometry, for example, if you want to track this cap with a model of cylinder, cylinder doesn't really describe the cap, especially it doesn't have the scandal. But at the same time, you can, for example, do not scan it. You can just try to make a kind of cone without the top and try to track it with probably pretty rough geometry of the handle. We'll try it a bit later. For example, yeah, let's try it right now. We have this model for this creature, but let's try to track this one, and even with not this model, like these models are basically, they are different, but let's create a model of sphere. And yeah, let's connect everything together. So camera, geometry, now sphere, and this background. And also I'll copy pre-analysis file. I will discuss what is it a bit later here. And yeah, let's try to place this. Sphere. It looks like sphere, but it's not sphere, definitely. Okay. Okay. Sphere is not that easy in placing. Okay, so like this, and what's going on? Okay, yeah. So something like this, and let's try to track it. To speed up the process, I will switch off the updating of background, and now it's like millions times faster. Oop. GeoTracker results. Sorry, it's a debug version. I'll switch off some. By the way, yeah, let's switch it back. Yeah, let's switch on it. Yeah, it lost the object at some point. Let's find where this point was. I'll switch off the resolution a bit. Let's take a look how it looks like. Okay. Yeah, I have definitely some issues with probably codec here. Let's wait while it will precalc the footage. And here it is. So we can track the object with a model which is pretty different from the object itself. But the better model you get, the better result, the better keyframes you can set up, and the better tracking and you can get at the end. One more thing, yeah, let's take a look at the different example. By the way, I want to try a bit different approach here. Let's take a look first how fast it will play the footage. Oh, this footage is much faster. Not that fast, but faster. I wanna add also. Let's first try to convert this footage to some for example JPEG sequence. Probably it will be a bit faster. Or TIFF sequence. Yeah, let's make TIFF sequence with DPX better. DPX. Okay, and let's render it. Oh. Yeah, probably everything is so slow because of the OBS and because it intensively converting this video right at the moment. And here on lockdown I have only my laptop at home, unfortunately. So but anyway, we're gonna track this car now, and we'll try to track this car with different models. Let's switch back to Safari. We discussed background, we discussed model, almost discussed model, and yeah, let's also discuss camera, I think. And yeah, we actually discussed it quite a lot last time on KeenTools, but the important thing regarding camera is that you have to know the focal length of the camera. If you don't know it, you can estimate using GeoTracker on KeenTools, but again, if you know it, it's better to use focal length information. So yeah, let's now read this file instead, and let's use it instead of okay, because now it works like a cache. Yeah, let's just simply read it again. Okay, let's check that it plays faster. Yeah, I think it's a bit faster. Not that much, but okay. So I have a car and a model of the car, and I found this model in the internet. So it's not precise model of this car, it's just model of the almost the same model. And let's connect them all. So geometry here, background and camera, and let's try to track it. So I first remove everything. Oh, camera neoplane is close to 0. It's because camera projection parameters, and I set this one to like this. Please always read all warnings here in GeoTracker, and we'll discuss them in details a bit later, some of them. But yeah, so let's set up the first keyframe. For example, the first there are some pins here. Remove all pins, CenterGeo. So I've set up the first keyframe. in the first frame, obviously. In GeoTracker, let's switch off all this stuff. Yeah, now it's more visible, I think. And yeah, let's now track it. Fix it a little. And let's take this range. You always need to wait while it will cache the range, because otherwise you can't check the tracking. Okay, something like this, probably not ideal, but you got the idea. But let's try to track the same model with, for example, a model of cube. And let's take a cube geometry. Of course, we're gonna make a cube of the same size like the model itself. And so I'm gonna drag it here, 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 just to match the proportions, and here. Okay, let's make it more precise a bit. Okay. Okay, and here we need it there. And yeah, let's just use it instead of the model. Here it is. And yeah, let's actually, we already have quite correct keyframes here, but let's try track it. So I will click track button, and despite of lots of wrong features here, it tries to track the model, but yeah, there are some issues, of course. Now let's click refine. It will calculate two trackers. I will discuss it a bit later again. Yeah, let's take a look what's going on. Cool. Not that good as the original model, but we can probably add a bit more keyframes and fix the incorrect tracking. So if you want, for example, add some dust or use it, yeah, let's click refine. And if you want to add some dust, for example, from the wheels, it probably pretty enough. You don't need just precise tracking. It should be just good enough. Yeah, let's take a look at it. Yeah, something like this. Well, we have a question here. After asks, can you touch on proper workflow for integrating other 3D objects together through the same camera, for example? I have a tracked 3D scene, which I need to have a geo-tracked object interact with 3D object in scene. Since geo-tracked objects seem to have their own placement and camera that may not relate to other objects. If that makes sense, let me understand the question. Well, if you track the objects from some tracked using one camera, some tracked camera, this camera, so all objects will track based on this camera and movement of this camera, and the only thing which could arise is scale of these objects, and then you can change the scale to make the objects to find a correct scale of the objects and to interact them in one scene. And you can track the objects first and then change the scale. Probably, if it was a question, I hope I answered it. Okay, so let's switch to our presentation. And at this point, we're gonna have 5-minute break, and then we'll oh no, let's first discuss camera. Okay, we also discussed that the important information about camera is sensor size and focal length, and the important thing that they all could be different from the ones you have in specification. So if you have a sensor size on a camera, the video sensor size could be a bit cropped. You have to measure it or find the correct one. Or, for example, for focal lengths, if it's written 35 on a lens, it could be 35 point something. So you can find the correct focal length using focal length estimation feature of GeoTracker, or basically just use the ones that from specification. But the important thing here is that actually it's one parameter. So you actually, the only important is the ratio of sensor size and focal length, and it's called equivalent focal length. And if you didn't understand what all this stuff about, please, I have to refer to the previous stream when we discussed all the stuff in details. And rear far clipping settings, it's basically it's not that important. It's like the issue which we just had with here when camera had really small clip, like near, like 0. The rendering could be really strange, and in GeoTracker there would be lots of different warnings, but one of this warning is pretty important as well, is that model is uncentered and refinement quality may suffer. What's mean uncentered model? It's when the pivot point of the model is outside of the bounding box. So let's take a look at this bottle. So to rotate this bottle, I usually do something like this. But let's imagine that we have a pivot point somewhere here. And to rotate this bottle like this, around this pivot point, I have to first rotate it around the pivot point and then move it. And I guess it's not the thing which you are want to from the tracker, and it actually just always make sure that the pivot point, which is 0, 0, 0 in Nuke, is always inside the model. And if you see this warning here, the model is uncentered, always fix it, because otherwise you can find you in trouble. So let's Okay, now fix the near and far clipping planes, and yeah, now we have this uncentered model, and you can easily fix it. For example, here in cube, just we can translate it back a little. For example, to the center, and in GeoTracker now everything should be okay when we track it, but we have to reset up the what's going on. Okay, so it seems we have some okay. Oh god, guys, I've forgotten to switch off my face. Sorry folks. Okay, I already showed you some issues with the camera here. Okay, let me show it again. For example, if I switch off 0, we have this. Okay, I think you saw it when I switch off, when I was talking about uncentered models. Okay, now yeah, I've already fixed it, I think, with just moving this cube. Yeah, did I fix it? Where is my cube? Strange thing. Probably I need to okay, I don't know what's going on, but anyway, if you see this warning, always fix it somehow. Well, now let's switch back to the presentation, and we discussed camera, and now we're gonna discuss GeoTracker pipeline, but before this let's have a small 5-minute break just to fill the bottles and have some drink and so on. So see you in 5 minutes, folks, and please ask your questions during this break. I will answer them right after the break. Okay, the break is over. Thank you all for waiting me, and let's go further. And now will be the most interesting and more practical part. And by the way, are you all here and can you hear me good? Please write if everything wrong. So, let's switch to the next part, which is basically GeoTracker pipeline. So let's discuss in details what you have to do to track the object. And well, more or less everything is consists of 5 steps. First of all, precalculation. So you have some pre-analysis first of the footage, and we'll discuss now what's inside this step. And then you set up first keyframe, then you track the object, and then if you see that object is slipped away, you can add more keyframes and refine everything between the keyframes. And so you basically split the sequence into different parts and track each part independently of all other parts. And then you have to export your results somehow. Okay, do we have any questions? To after asks again, to clarify my question, so we have 3D camera track. Yeah, so if you have 3D camera track, you can use it as a camera for GeoTracker. And then you have to export TransfomGeo. Yeah, exactly. Yeah, so we will take a look at it. For example, in this footage with auto. So, first of all, precalculation. What's inside? So basically, precalculation is the phase of 2D analysis of the footage. So we calculate motion vectors, optical flow, as you wish, and we find corners, blobs, and so on, and track them. So it's like the camera footage analysis in camera tracker. Basically, it's the same, but we then store all this information inside the special precalc file. So let's take a look at it. Let's, for example, open this footage with foxes, close this pane, switch back to original resolution, and delete everything here. Okay, let's open GeoTracker, and let's say I want to calculate for foxes for precalc file. So I have to write some random name here, just to give a name to this precalculation file, and hit analysis button. So no settings, and it could be automated and made before the actual tracking. So, and then I hit analyze, and it will take not that long, like 5 minutes for this shot of 200 frames, but I don't want to wait for it because I already calculated it. And let's take a look what's inside this file. So we have internal instrument for this. It's called flow evaluation tool. Unfortunately, it's not available for you for now. We later will add this tool inside GeoTracker, I think, someday. But for now, you can take a look what's stored inside precalc files. There are lots of features, huge number of features, and we calculate them quite efficiently. Together with every feature here has a line out of it, and this line corresponds to movement to the previous frame. So we try to extract everything from the footage, so the best information we can extract from it. And then we can use this precalc file for track all objects in this shot. And let's apply some thresholds to better see. So for example, we can leave only good features here, and with both parameters. I filter out some fast moving features here. It's quality of threshold. We have lots of internal metrics inside, like quality of corner, quality of flow, and so on. And we can then use these metrics for better tracking. And basically that's it. That's what's stored inside precalc file. So why we created it? Because obviously it could be calculated during the tracking. The main reason for this is that we tried to speed up the process of tracking as fast as we could. So because the actual thing which is matters is man hours, so the time which you spend working with the tool, because computer time is not really that important, and you can automate the precalculation process and make it during the night or on rendering farms and so on, and it will so basically lots the portion of this time when you track the footage, the original 2D tracking, will be just excluded from your time of manipulation with the tool. The other reason for this is that actually we analyze the whole footage, and that's why you then can use this precalculation file for all objects, including faces, and you can use the same precalc file in face tracker as well. Okay, so one more thing, and that we released a new version yesterday, 2.0.2, and now there is a GPU support for precalculation on times faster result, basically with the same quality. So now you know about it. Okay. Sorry. Let's also discuss some pre-processing, and it's pretty important stuff, I'd say. So let's switch it off. So the original footage here is make it more sharpened. For example, there is a traditional pipeline for this with blur, and we can blur the image a little bit, like this. Then we can merge it with the original image in a minus with a minus. Then we can, and we get something like this. Probably we better switch the inputs, and then we can merge it again with the original input in plus mode. So let's switch it. And here we can add also some mathematical, how it's called, multiply mathematical operation to make it more vivid. So here it is. It was the original footage, and this one is more sharpened one. You may see the difference. Lots of small details are now visible and looks like a corner for 2D tracker. And usually you have to do it in all other trackers, but not in GeoTracker. GeoTracker does exactly the same stuff internally, okay, a bit different stuff, and also normalize it and make it so it really tries to extract all the features that could be extracted from the footage. And that's why generally you don't need do any pre-processing for the footage. One more thing to discuss is motion, blur, and noise. So if you have, for example, dark shot, when you shoot it, you can either make the shutter smaller, and then you get less motion blur. But in that case, you have to increase ISO, and it will give you more noise. And or backwards, you can have less noise but more motion blur. What is better for tracking? For tracking, better noise. So motion blur, it's really hard to tackle motion blur shots. So always, please, if you have a chance, make the shutter smaller, and probably with a bit more noise, but it would be much better than motion blur. But if you can't control shutter, especially on main camera, but you can control shutter on witnesses. So if you have witness cameras, please make motion blur smaller on them, and then you can use them for tracking. Okay, what's going on here? Okay, so the next step, setting up the first keyframe. And we discussed a lot the process of setting up keyframes, because basically what PinTool node does, and it's free tool for locating the object in 3D space, and GeoTracker does exactly the same, but it can also track the object. But the important question, which we didn't discuss last time, is where to put this initial keyframe. And if, for example, we take a look at this footage with the car, so let's delete the tracking and let's take a look at this footage. So there are pretty a lot of different frames. Like this, these. So let's say you want to find a first frame, first initial keyframe. For example, would be this frame a good candidate for this initial keyframe? I don't think so. For example, because let's put a keyframe here. Let's remove pins, and even I understand where. Can you see these handles? I can't see them. Let's change the handle size and preferences. Where it is viewer, no, handles, 2D handle size, probably this one. Oh, now they're bigger. So I can set up keyframe like this. I can, but honestly, I'm not sure about position of this part because I simply can't see it. So the best keyframe, the best initial keyframe would be the point when you can clearly see how the object looks like and where it's located. So here I'm gonna, for example, take this shot for this. So I put keyframe here, pin here, and here. This one is also good because of this visible lights on the back part of the car. So something like this, and it would be our first initial keyframe. And then you can track the object, and it's a good practice to click this button over there, which is full frame processing, in order you can later zoom back and forth to verify your tracking. Okay, let's switch it. It's still okay, but when it was tracking, let's do it again. You can see that it looks a bit slipped away, but actually it's because it always Nuke draws the footage a bit slowly and one frame back always. So you always need to verify your tracking by caching the footage. Like, it's still okay. No, not that okay. Let's fix it a bit, and let's now click refine. Oh, sorry, I going a bit further. Sorry. Okay, so we actually tracked the object, and yeah, let's take this part, and yeah, again, full frame processing, and now independently of the zoom level, it will always play in real time. So let's wait a little for this. The cool thing that you can click track backward and forward. That's why you can select any initial keyframe for tracking. Oop, it's some strange frame where it was. Some Nuke cache problem. Where it was? Ah, something like this. Oh, now it's okay. Yeah. So looks good, but to speed up the process of tracking itself, you can switch off this button and click pause button, and then click track forward, and it will track much faster because it won't show you what's going on. But then you can switch it on and look at the result. And let's track backward. Oh, too slow. Let's switch it off. and verify the result. Pretty okay. We will fix it a bit later. And yeah, something like this. Refinement. So yeah, obviously we need to refine it. So you can set up keyframe at any moment and then click refine button. And it will automatically refine the range between this keyframe and the next one. For example, here I want to add one more keyframe to fix this thing. And then when you clearly see some jump, yeah, because this keyframe is new and we had this old tracking here. So to fix the jump, I again need to click refine. If I click refine and my playhead here in the range between the keyframes, it will refine the range between the keyframes. But if I click refine just after I set up the keyframe and my playhead on a keyframe, then it will refine both ranges to the left and to the right to the next keyframe. And here it is. Let's switch full frame processing back. So now how it looks like. And let's calculate the cache for the last. You have to understand that it's not tracking now, it's just calculating of the cache of the footage. Unfortunately, Nuke is not real-time software. Okay, now we track this footage using just 4 keyframes. It could be tracked even with 3 keyframes, I think, but could you try it in some other software? How many keyframes you have to use? Okay, let's switch back to the presentation and discuss how refinement works. So we have 2 keyframes, and we definitely can track backward and forward from both keyframes, and then at some point we understand that tracking process goes somewhere, it's not that reliable, and at this point we can try to merge both trajectories of movement of the object together and merge them together based on some statistics and information on tracking, and find the curve which goes through both keyframes. So what you need to know about the refinement process. First, we already discussed how to do it. Also, one more thing. There is a small button here, not everybody knows about it. It's called clear between keyframes, and you can click on it and it will remove all tracking information between the keyframes, and it will just interpolate this information between them. And sometimes, especially when you have lots of motion blur, it would be even better. Obviously not not this time, because there are lots of small movements, you see, but it's pretty okay. Yeah, it's pretty okay, but I think tracking would be better. Yeah. Okay, so And the last thing which we are going to discuss is where to set up keyframes. And there are several strategies. And one strategy is I want to add keyframe at first frame of the shot, then I will track forward, then at some point I will stop the process if I see that something goes wrong. I set up keyframe and then refine this range, and if something goes wrong I'll add additional keyframe, for example in the middle or in the point with the biggest error. And this strategy basically works quite well, but the thing is that sometimes it will lead you to many excessive keyframes, and that's why it would be better always to set up keyframes based on the movement of the object. For example, if you have like in this car you have movement consists of several, actually it's a rotation, and you definitely need to set up keyframe, for example to fix some between. Everything is so good here, but for example if the head moves and then stopped, then it's better to set up keyframe when the movement changes and you can split the footage with some more static part and more hectic part. So that's why keyframes really helps the whole procedure. And if you set up keyframes in some semantic frames, it will minimize their number, and you will basically have less number of keyframes and the better quality of the tracking. Okay, results. So how to verify your result? For example, one way to do it is this center view button here. So if I click on it, it will place the object in the center and move the frame around it. So it preserves the position of the object, and it's much easier to see if something wrong with the tracker. Also, it's very important to match the motion blur. And for example, in this shot there is not so many motion blur, I think. But if I switch motion blur here, now I can see motion blur on the edge of the model. And if I set up parameters right, like the shutter parameters, samples count, and so on. Samples count is mostly for you, but shutter parameter depends how big is motion blur. But you can match it and then verify that motion blur looks okay on all shots, on all frames of your shot. By the way, I'd say it's a good point to set up additional keyframe here. Mostly it's because the wrong model. You see, this edge looks okay, but the model itself, it's not that easy to match the model. Okay, but what is more important, okay, let's by the way delete this stuff, is to verify the tracking in 3D. So as After asks this time camera is actually tracked. It's static camera, but it's rotating. And the object moves according to this camera. And here we can see some issue in our tracking. Can you see this small jump here? Yeah, let's take a look at it one more time. I can see it now. Yeah, it's pretty okay. One more thing to verify your one more way to verify your tracking is take a look at curves. So, for example, here it's our rotation curves. They're quite smooth. Let's now take a look at translations curves. They are smooth as well. So everything is pretty okay. It means that you can use these tracking results. One very important thing which you need to know about geometry tracking and actually any single view tracking. So if there is not enough parallax, you can't actually understand the distance from the camera to object. For example, like in these problems called Z problem, or it leads to some jittering in Z direction. So let's take a look at this bottle, and I will move it 5 centimeters left, 5 centimeters in Y direction. And now let's take a look what's going on in Z direction. Also, again, 5 centimeters. You can't actually see it except some slight changes in scale. And it leads to some easy jittering in Z direction. And next time we will discuss how to tackle with this Z jittering, how to smooth everything and make the tracking as smooth as it could be done using one camera. But this time let's discuss first some basic stuff, like for example exporting options. So as you noticed, GeoTracker itself works like a TransfomGeo. So it moves the geometry which you have as an input. But here in GeoTracker you can export here. Export the TransfomGeo and apply it to if we apply it to the original object, it will basically exactly the same like the GeoTracker itself. But if, for example, you want to attach some additional object, like let's say I want to attach some cube. Where's my cube? Where's my car? Let's switch it off. Let's open my cube. Let's say I want to put some rocket missiles on this car. So I'm gonna put it here. And now I can apply this TransfomGeo, and let's take a look how it will look from the camera view. So I'm gonna create scanline render and scene with some light, of course, some directional light, and with this scene and this background and the original camera, and how it looks like. I need also add some material to our cube. Add apply material, basic material. Okay, something like this. So now my cube, which is rocket launch system, is attached to my car. While it's calculating, I will answer your questions. So Jody asked high pass filter. Well, if this question was about some pre-processing for the input image, no, you don't need high pass filter. So yeah, something like this. Okay, so the next exporting option in GeoTracker is axis. So instead of TransfomGeo, sometimes you need axis, and it would be much easier to, for example, if you want to attach some moving camera to the object or something like this. So sometimes you just need axis. Basically, it would be the same axis like TransfomGeo. Also, as we discussed last time, you can export camera if you change the focal length parameters. And the last thing is tracked camera. And this stuff I want to show probably in more details. And let's open scene with some camera tracking. So here we have a footage, and with a moving camera, a bit with quite a lot of jittering. It's pretty long footage. At the end, we have also some zoom and change in focal length. So let's try to mesh this camera. So I've created a GeoTracker here, and this, and let's create new GeoTracker. And I have a model of it's pretty rough model of this scene, and let me connect everything. For camera, I actually don't know anything about this camera, so it's just a standard camera. I can delete it and create a new one. And let's set up a first keyframe. In this particular case, probably the base point would be, for example, just the beginning of this sequence. So I click Center Geo, and I'll try to pin this model to my scene. Oh, let's better catch this point. It's here. This should be where? Here. Something works not that good, probably, most likely, because of the wrong camera parameters. Okay, let's remove all pins again. So this step is here, this one is here, this one is here, and this goes here. But you can clearly see that you can't match this footage with this focal length. And that's why we can say in GeoTracker that we will use not the focal length from the camera, but some custom constant focal length. For now, let's say it constant. But we know that as the... Okay, let's say it's varying focal length because we know that there is some zoom in this camera. So, and here we have a small tick called estimate focal length. And now, when I drag the points, it will automatically change the focal length parameter as well, and it will let's set one more point here, and it will try to match the footage. You see, it changed the perspective and focal length as well. So now it's pretty okay. So something like this. And you see now the correct focal length parameter is not 50, it's like around 16 or 17. And now I can track this footage, and if I click track, it say, hey, where's your pre-analysis file? And I will just copy and paste it here because it's already calculated. And then I can click track button. So now it tracks, actually it tracks the object now, not the camera. So it for GeoTracker it doesn't matter. Track the object or track the camera. The only thing which is which really matters is what you export from the GeoTracker. So, and this time we will export tracked camera. So now we're here, and now we're gonna zoom. We're gonna have zoom. And actually it will fail to track the zoom because I didn't switch it on. It tracks it somehow, but you see there are some issues here. So where was this moment? Like here, yeah? So here I set up keyframe. So I isolated the previous part, which is already tracked, and it was tracked good. And now I will click this small tick here, tracked with focal length estimation. So now it will track focal length as well. And let's try again. Yeah, now it tracked the focal length changes, and you see focal length is increasing. Here it is. Everything looks pretty okay. We'll catch the footage. And zoom. Voila. So everything is pretty easy. But now let's export this tracked camera. So in GeoTracker we export in results tracked camera, and let's create scene for them, because we need now the original geometry and this camera. So I'll switch everything else off. And here it is. Here our camera. And now zooming. Can you see that it's slightly jittering? That's exactly this Z jittering thing. And to prevent it from jittering, here on results tab we have several ticks like fix camera or object, and fix rotations and translations of the object. So now I can go back to my keyframe here and track it again with all fixeds. Now my camera is static and only focal length is changing. And here we have probably a bit. Let's estimate focal length for this shot. Yes, here we probably have clearly see that we have some inaccuracies in this model. Otherwise it would be easy to fix it. Yes, so yeah, so but let's switch back in 3D. So okay, because we look at GeoTracker, we have see how the object is moving now, but let's switch my viewer to the scene and hide GeoTracker. Here it is. Now the camera is pretty static when it should be static. We have a question here. So in this example, if the girl's head was moving and I wanted to track that, would I track the camera first like you did first and then do another GeoTracker for her head? Exactly. So if you guys have some time for this, actually it's almost the last thing for today's stream. We already discussed camera tracker, and but yeah, let's track her head as well. Actually this time we don't have a exact she doesn't move her hand, but yeah, you first create the tracked camera and then you create a new GeoTracker for this and use the geometry. Okay, for this we'll take a face builder, for example. Use this geometry result of face builder, this camera and the same background, and now when in GeoTracker we place the object, So yeah, let's remove pins. It's not her face, but some, okay, some face. We will not dig into face building at this moment. It will be a bit later, but okay, something like this. So now I have a GeoTracker and I place the model. It will slip away because of the wrong scale, because if I switch to 3D and open my where's my original model, this head is much bigger in scale than the original model, so I need to find the correct scale for this. And let's drag this, not this one, but the one in GeoTracker. On the results tab there is a scale, and we can try to find a scale parameters which will match the camera movement. And here it is. There's some inaccuracies in where's the tracking? Values. Yeah, something like this. Oops. So yeah, no, again you can set up some keyframes because I did it pretty rough. So yeah, let's set up keyframe for this here, and now we can track this face because she probably slightly changed its position. Oh, I need pre-analysis file again. And the cool thing that I can use exactly the same pre-analysis file. And yeah, let's click refine. Okay, I did it a bit early. Like here I should do it. So yeah, let's okay, so let's remove the previous keyframe. Go to this one, remove it, and now fix it position. Yeah, something like this to get the correct position, something like this. And yeah, now I can refine it, and then let's take a look at the result. So as you don't need the same or separate precalc file for the second GeoTracker node, yeah, as I just showed, you don't need as the other precalc file. Jody say that I think the precalc may be a motion vector pass. Actually, the first incarnation of precalc-file was exactly motion vectors, and we could experiment. We experimented with different motion vectors and so on. But yeah, it seems we've tracked it. But for better results, we now have our own format of the precalculation file, because it's not only motion vectors but also some quality metrics on top of the vector path, which is pretty important for tracking. So yeah, here's the result. Let's remove pins. Something like this. So now we've matched her face as well. Let's have a full frame processing. Let's switch back to our presentation. So we need to discuss masks a bit. So there are two. The last input is mask, and there are actually two different masks in GeoTracker. So one is two-dimensional mask and the other one is three-dimensional mask. So what is 2D mask? It's just ordinary rotor node, and when you let's take a look at the result. Here I think the center view button would be the best option. So yeah, we've tracked the face as well with pretty rough model. Okay, so regarding the masks, so you can create just ordinary rotor or alpha mask or something like this here, and then use it in GeoTracker, because like source alpha, mask alpha, or inverted alphas. But also you can create 3D masks with this small brush here, and you can change brush radius like this, or with shift drag, and what's going on? It's changing, but yeah. So you can draw mask on top of the model, and it will exclude this part from the solver as well. So for example here I'm gonna exclude everything with her hair, like this and this. So it would be, and with a right click I can delete the surface mask, and it will improve the quality of the tracking, but we will discuss it in more details next time when we will tackle with complex shots. So next time we'll discuss when to use masks and when to use user tracks, how to use UV for unwrapping or changing, testing your tracking and so on, how to apply some restrictions and smooth your solver, how to tackle with Z-jittering, and how to work with multiple views and witnesses cameras. And if you have some footage which you want to share with us, we will prepare the demo exactly on your footage and show it on the next stream. So if it's applicable for you and this footage it could be shared with the community, please send us your examples and we will show it next time. Okay, so now questions. We have one comment from After. I think you guys just need to make a good camera tracker plugin for Nuke. Oh yeah, it's actually possible. But to be honest, if you know how to use camera tracker for Nuke, you can get pretty awesome results out of it. And I really think that the instrument itself, the algorithms, they matter and the instruments matter, but if you know how to use your instrument good, then you actually can get really brilliant results. Do we have any more questions? Seems there are no more questions at this point. So guys, please share your feedback about the stream itself, probably your questions and some ideas for new streams using this link, and we will post this link in the comments, in the chat, and in comments under the video. So please, I know there could be some issues. For example, this stream appeared to be really long. I didn't expect it, like 2 hours, and also some connection troubles and so on. So please file it. We need your feedback as well. Oh, sorry for my English. We need your feedback, guys, really a lot. And also, please subscribe for our newsletter. We'll sell the recording and some materials as soon as they are appeared, and join party in the Discord. We discuss your stuff here, and you can ask your questions in the Discord, or writing us on an official email. We answer everybody. So questions again. I will wait probably for several minutes here. Because of the lag. So, oh, it was hard today. Really, guys. So, it seems we don't have any more questions at this point. So, guys, thank you a lot for your attention, for your time, and please join us the next time. Thank you all, guys. Bye.